Okay, in simplifying this complex fraction, I'm going to be dealing exclusively with the numerator, and then once I've gotten that to a single fraction, I'll come back and work exclusively with the denominator. So I'm going to rewrite my 1 as 1 over 1, any whole number as over 1, and then think about what's my least common denominator. So what I like to think of is, what does this denominator have that this denominator needs? This denominator has an x squared. This one certainly needs that. And so I will multiply by x squared over x squared. Put those in parentheses. And then I'd ask myself the same, what does this denominator have that this one needs? Well, this doesn't have anything that this doesn't already have. This has an x squared, this now has an x squared, this has a 1x squared, this has a 1x squared, so I don't need to multiply the 9 over x squared by any other factors. So I'm going to rewrite. X squared times 1 is just x squared over the x squared times 1 is x squared. Take away 9 over x squared. Now that I have a least common denominator, I can combine those fractions into x squared, take away 9 all over x squared. And what I notice here is, if you take a look at this x squared minus 9, hopefully that's, when you see that, red flags are getting waved at you, and you recognize that as a difference of squares. X squared is a perfect square, 9 is a perfect square. You are subtracting, so this is a difference of squares, which will get factored into x plus 3. X plus 3 times x minus 3 all over x squared. And we're done with the numerator. So now we'll travel back to this denominator here, and we'll consider that for a minute. First I'm going to write any whole numbers as over 1, and then I consider what does this denominator have that this denominator needs. This denominator has 1x squared, this just has a 1, so I need to multiply by a factor of x squared over x squared. So then I ask myself, what does this denominator have that the middle denominator needs? This has x squared, this only has x to the first power, so the 5 over x needs another power of x in the denominator. So I'm going to multiply by x over x. So now, when I consider this, I have x squared in the denominator, x times x is x squared in the denominator, x squared in the denominator, and I have a common denominator. So I'm going to add these together. X squared times 1 is x squared plus 5x plus 6. And then the common denominator was x squared. And right now I'm looking at this trinomial, and I'm thinking to myself, are there any factors of 6 that add up to 5? And so I'm thinking, okay, well 1 and 6 don't add up to 5, but 2 and 3 do. So I know that this can be factored into a product of two binomials. X, x, and we're going to need a plus 2 and a plus 3, because 2 times 3 makes 6, and then the 2 plus the 3 make the 5, all over x squared. And so I'm done there. I'm going to just go ahead and write it right down here. I'm just going to rewrite 2x plus 3 all over x squared. Let's put an equals up here. There we go. And now I'm ready to multiply by my reciprocal. X squared over x plus 2, x plus 3, and in the numerator as well. X squared over x plus 2 x plus 3, and let's see what we can reduce. X plus 2's, same top and bottom, x squared, same top and bottom. From the top, x squared and x squared reduce. X plus 3 is the same as x plus 3. And so it looks like we're left with an x minus 3. Let me go back, sorry. X minus 3 on top. All over. Looks like an x plus 2 on the bottom, and everything else reduced. On top, uh-oh.